Hi everybody, it's Mrs. Mancuso with another chemistry review. Today's topic is going to be isotopes. So isotopes are what you have when you have more than one atom of the same element, but they have a different mass. And that different mass cannot be due to the protons, because if it's the same element, it must have the same number of protons. That's what identifies an element, so I have to keep these the same. So what can be different about the mass? Well, we know the mass is equal to the protons plus the neutrons. So mass is equal to P plus N. This can't change, so the thing that is different is the number of neutrons. And if I take my reference table and I look closely at any of the masses, you'll see that they all go to these decimals. And that's telling me that on the periodic table, all of those are the average atomic mass of all of the elements that the atoms that exist. So all of the different isotopes that exist for an element, the average of those is their atomic mass. Now the average is based on their relative abundance. That means that out there on the Earth, there can be different amounts of each different isotope. So what I did was I looked up an example. So here's an example of iron. Iron exists in 4 different isotopes naturally, and these are the abundance. So this is out of 100%, how many atoms are iron 54? Now iron tells you the type of atom, 54 is telling you the mass. So out of all the iron atoms on Earth, 5.8% of them are iron 54. And what 54 tells us, I can say 54, the atomic mass, minus the number. So I gotta go look up iron's atomic number, and it's 26. So 54 minus 26, these ones have 28 neutrons. And then out of all the iron atoms, 91.8%. So the majority of iron out there is iron 56. So 56 minus 26, these atoms have 30 neutrons. So see, this is what's different. They differ in their number of neutrons. And then this one would obviously have 31 neutrons, and this one would have 32 neutrons. So that's how I figure out how each one is different. This is by far in the smallest abundance. It's very rare to find an atom of iron 58. Now, if I want to find the average atomic mass, or I want to show the correct numerical setup, which is a really common thing for them to do on the Regents, what I need to do is, I'm going to turn my paper this way because it tends to be pretty long. I am going to take the mass times the abundance for each element. I put it in parentheses. So 54 times 5.8. And then I'm going to add that to the next mass times abundance. 56 times 91.8 plus, and the next one is 57 times 2.1 plus the last one, 58 times 0.3. Okay, so there's all 4 of my isotopes, mass times abundance plus mass times abundance. So it's really important, if they ask you to do the correct numerical setup, that you set it up like this, using parentheses to show mass times abundance, so that your order of operations is you would solve what's in the parentheses first and then add them together. And the last thing I need to do is show that I would have to divide this by 100, because all of these were percentages, which means in actual abundance, I would have to move that over 2 decimal places. So if I just divide the last thing by 100, I will have the correct amount. Okay. Please join me for more review.